Good day, everyone. Today we're gonna look at the second question for paper one. That is physical science. We're just gonna look at the Newton's laws. So let's get into it. So an 8 kg block on a rough horizontal surface, that is a statement, is connected to a 2 kg block by a light intensible string passing over a frictionless pulley as shown below. So they are talking about this system. The 8 kg block, here is the 8 kg block, moves at a constant speed, and the constant speed there is written in bold. When pulled by a 29,6 newtons horizontal force to the right, the frictional force acting on the 8 kg block here means that it is on the rough surface here. So the frictional force and then the frictional force will be present if it's on the rough surface. That is why they said the frictional force acting on the 8 kg block here is 10 newtons. So the first question says 2.1 state Newton's second law of motion in words. So let's get into it. 2.1 Newton's second law of motion in words. I write it like this. I'd say F net is equals to MA, because I believe that the definitions are derived from the word from the equation. Now it says here an object will accelerate in the direction of the net force, and the acceleration is directly proportional to the net force. So it means that F net is directly proportional to A, and then inversely proportional to the mass of an object. So the acceleration over here now is inversely proportional to the mass of an object. So yeah, that is the definition for the Newton's second law. It says that the object will accelerate in the direction of the net force, and the acceleration is directly proportional to the net force and inversely proportional to its mass of an object. So now let's look at the second question. 2.2, it says here, draw a labeled free body diagram for the 8 kg block. That is 5 marks there, if you can see that. So 8 kg block, let's draw the free body diagram. 2.2, the 8 kg block. Now as you know that we have the gravitational force, that is Fg, and we have the normal force when the object is placed on a surface. So if an object is placed on a surface, we have the normal force, and then if the object is moving over a rough horizontal surface, it means that it experiences a frictional force. And then so now let's look at the forces that we have here. So now we say now the Fg, because we have the gravitational force because it pulls the object downwards. And then now if the object is on the surface, it means that we have a normal force. As you can see that it's on a surface, horizontal surface there. So it means that we have the normal force. So this one is Fn, and then this one is Fg. And then now they told us this object is pulled by 29.6 newtons. It means that we have the applied force there. So this one is an applied force, Fa. And then now let's look at since they say that the frictional force acting on the 8 kg block is 10 newtons, it means that it experiences a frictional force. It means that it's moving on a rough surface. So we show the frictional force by Fk. So now, since we have here the tension, as you can see that it's connecting these two blocks over here, so it means that we have the tension over there, tension force. So we represent what? A tension over here. So this one is a tension. And if you can count these forces, labeled forces over here, labeled arrows, stands for the forces. It means that 1, it's a normal force, 2, it's an applied force, 3 is a gravitational force, we have the frictional force, we have a what? We have a tension. So let's count 1, 2, 3, 4, 5. And the marks that I told you about, it's 5. It means that the forces are well represented there. So now they say, let's calculate the tension in the string, 2.3 over there. So let's say 2.3 now. They say let's calculate the what? The tension in the string. We are calculating the tension there in the string. So let's get into it. And yeah, Newton's second law, it says that F net is equals to ma. Let's look at that first of all. This is the equation that we use. Now, let's go back to the statement. The 8 kg block moves at a constant speed, and the constant speed there is written in bold. It means that it has something that it says. So when you have the constant speed, it means that we have the acceleration of an object, the acceleration that is equals to 0 meters per second square. And then we have the what? Since F net is equal to ma, it means that the F net is equals to 0 newtons. Because if we are substituting a 0 there in place of the acceleration, we get a mass times a 0, and then it ends up being a 0, and then we have the F net as a 0, and then we have the W net as a 0, as equals to 0. So now let's get straight to the question and see if how can we approach this one now. So we say, first of all, we say F net is equals to ma, and then we say F net is equals to m times a 0. It becomes a 0. And then now let's look at the F net. We have this free body diagram over here, and then we take these forces as our F net. So we have the applied force, we have the friction, and then we have the tension. So let's choose the side where the system goes as our positive. So it means that we are choosing this side as a positive now. So when we attack this question, we will say F applied is minus now, because the tension is going in the opposite direction. It's minus T, and then minus also the frictional force, because it's going in the opposite direction, and that is equals to a 0. And then the applied force, they say it is a 29.6 minus, we don't have the tension, that is what we are calculating, and then we have the friction, that is negative 10 newtons, and then it's equals to a 0. And then now we say 29 minus a 10, it gives us a 19.6, and then we say a minus a t is equals to a 0. And then now we say we transpose a t into over there to the other side, and then we get a t is equals to a 19.6 newtons. That is our tension over here. That is our tension. Let's yeah. That is our tension. Tension in the string. So that is our tension over here. So yeah, let's look at 22.4. Let's quickly look at 2.4. Yeah. So now let's look at 2.4. And then So yeah, 2-point force here says the 29.6 newtons horizontal force is now increased to 50 newtons. So it means that this force here that was 29 and is increased to 50 newtons. And then now let's see what they say. We should calculate. So they say apply Newton's second law to each block and calculate the magnitude of the acceleration of the 8 kg block. So it means that we are calculating the acceleration of the system. Let's get into it. So yeah, let's see. So here, according to the free body diagram that we drew, we have those three forces there. That is the one that are making the F net. And then now let's try to draw the free body diagram for the 2 kg block and also for the 8 kg block, and then we find the acceleration because we're gonna need them. So let's say for the 2 kg block, 2 kg block here, now we're drawing, and then the 8 kg block over here. 8 kg block. Since we drew the 8 kg block, we know that it has five forces that are acting there. That is, we have Fn, and then we have the Fg, and then we have the tension, and then we have the friction. Here, the tension, and then we have the friction, and then we have the applied force. So we have the applied force. If applied. So now let's use Newton's second law. We say F net is equals to ma, and then we say the direction that is moving, the direction to the right is a positive. So it means that we have the applied force, F applied, minus the tension minus the friction is equals to ma now. And then now let's look at the 2 kg block over here. And then the 2 kg block, we know that this one is the tension. So it means that we have the tension, and then the block is not on the surface. It's on the it's connected only on the frictionless pulley, and then it's not on the surface. So it means that we don't have a normal force, but we have the gravitational force that is pulling the object downward. So we have two forces there, that is Fg. Let's look at them, Fg, and then we have also the tension there. So this is our free body diagram for the 2 kg block. So we have the tension over here, and then let's look at the Newton's second law, and we say F net is equals to ma. And then now we say the direction that is to the right, it's a positive. So it means that our t over here should be positive, and then our Fg should be negative. And then we have the ma. And then now let's replace. We know that Fg is equals to mg. So let's say over here t minus mg is equals to ma. And then now let's start to substitute things that we have, the values that we have here. So we have the block that is 2 kg over here. So it means that we say t minus 2, and then for g it's a 9.8, it's a constant 9.8, and then is equals to m. We put a 2, and then the acceleration is what we want. So this one should be our equation 1. And then the applied force, now they increased the applied force. Remember, they say that is now increased to 50 newtons. And then now let's say 50 newtons minus t, because we don't have a t, minus the friction doesn't change. It's still 10 newtons, and then it's equals to m. Now here is 8, and then the acceleration is what we want. So this one should be our equation 2. And then now let's work out the acceleration here. So in order for us to find the acceleration in this type of question, we need to add up the two equations. So we add equation 2 and equation 1. So we add up them, and then now let's add up those equations. T minus 2.2 times 9.8, it gives us a negative 19.6, and then is equals to a 2a. And then now we look at this equation 2, 50 newtons minus a 10, we'll get a 40. We say 40 minus a t is equals to 8a. And then now, don't forget that we are adding these equations. And then now, when we add this equation, we will say 2a plus a 8a, it gives us a 10a. And then now a t that is positive with the t that is negative, they cancel them. They cancel each other, and then we are left with the over here. We are left with a 40 minus 19.6. We are left with a 40 minus a 10.6. Let's find out if 40 minus 19.6 gives us a 20.4. So we have the 20.4 over this side. So let's divide with a 10. Let's say divide by 10, divide by 10, and then we get the acceleration that is equals to so the acceleration over here is a 2.04 meters per second square. That is the acceleration. So now let's look at the acceleration of the 8 kg block. But because this one we are talking about the system, if this one moves at an acceleration of 8 kg of a 2.04 meter per second square, it means that also this one will move at the same acceleration, because this one is a system. So yeah, the acceleration is 2.04 meters per second square. So we're done with the 2.41. Then now 2.42. Let's find out the tension in the string. Let's calculate the tension in the string. So yeah, now let me try to write it here because it's 2 marks. So we have these equations over here, and then they have the tension with them. So it means that we can take the so now let me say 2.4.2 here. So we have the tension in this. We have the tension over here in this equation 1. It means that we can pick one of these equations and try to find the tension in the string. So we can just take equation 1 and say T minus 19.6 is equals to 2a. This equation, it can help us to find the tension, because we have the acceleration there as a 2.04. Now let's try to find it. So T minus 19.6 is equals to 2 into 2.04, and then now let's try to transpose this 19 into the other side, and 2 into 2.04 plus 19.6. And then now let's punch out our calculator and see 0.04 plus 19.6. So our tension here should be 23.68 newtons. So that's our tension over here. And now we are done with this question because this one was the last question. So 2.42 was our last question. So you get your 17 marks, full of them, full 17 marks. Just make sure that, guys, you do subscribe, you like the video, and also you do comment in the comment section, because that helps me a lot to reach more people. And please do subscribe for me, so that I can reach at least 100 subscribers this year. Until we meet in the next video, please do take care.